This is the screencast for section 2.6, example 7. Well, back in example 3, we talked about the 3 different situations that would cause an end behavior asymptote. If the degree in the numerator and denominator are the same, you use the leading coefficients to determine the horizontal end behavior asymptote. If the degree in the denominator is bigger, then the end behavior horizontal asymptote is y equals 0. But then we haven't really seen any of the other examples where the degree in the numerator is higher. So in example 7 here, we're going to explore that. It says find the end behavior asymptote of f of x and graph it together with f in 2 windows. So we're going to first find the end behavior asymptote. To find that, we have to actually do the division, and we know how to do that using synthetic division. So I'm going to plug in 1 and go through synthetic division. So from the results of my synthetic division, f of x can also be written as x squared minus 2x plus 1 plus the 2 that remain to be divided by x minus 1. Therefore, my end behavior asymptote will be the quotient of that function, x squared minus 2x plus 1. So in y1, I'm going to graph the original function, and in y2, I'm going to graph the quotient. So I have the graph of the original function that has a vertical asymptote at x equals 1 because 1 makes the denominator 0 only. Then the other one is more of a parabolic shape because, well, it is a parabolic shape because it comes from a quadratic expression. Part A asks us to express this in a window showing the details around the vertical asymptote of f. So around the vertical asymptote, so I need to shrink down my x min and x max a little bit, and maybe shrink down the y min and y max too. So now I can see the original graphing, and now this new one, so it acts nothing like the original in the middle. But part B asks us to graph the 2 functions so that f and the quotient that we found have the same end behavior asymptote. So that means I have to zoom out to see what the ends look like. Now I played around with the windows a little bit, and because the end behaviors are supposed to look the same, f is supposed to resemble its end behavior, I'm going to want to make the end behavior dark, because if they look very close to the same function, I won't be able to see the 2 graphs separately. So if I make y2 dark, I should be able to see both functions graph. So that was my original function that does have the vertical asymptote, and now here's the new one that graphs right on top of it. They look almost like the exact same function. But you can see that in y1, I still have the original function, which is cubic divided by x minus 1, and the end behavior asymptote is x squared minus 2x plus 1. Well, the whole reason is an end behavior asymptote will act towards the ends like the original function. The now try problem is number 47. We're going to find the end behavior asymptote of the given rational function and graph it together with f in 2 different windows, very similar to like we did in example 7. So first I'm going to take the negative 2 that makes the denominator 0, the k value, and put it in synthetic division. Don't forget to leave your coefficients as 1, negative 1, 0, and 1. So my end behavior asymptote is x squared minus 3x plus 6. F of x itself has a remainder of 11. Again, so the end behavior asymptote is x squared minus 3x plus 6, everything except for the remainder. So I'm going to put the original function in y1 and the quotient in y2, its end behavior asymptote. So after playing around with the windows a little bit, I found a good window that will show the details around the vertical asymptote of f. So we can see the f function graphing with the vertical asymptote at x equals negative 2. And then here's the other function graphing, y2 graphing. So they look nothing like each other in the middle. However, because x squared minus 3x plus 6 is the end behavior asymptote, or end behavior function, they are going to behave the same, similar, at the ends of the functions. So now I need to do that with my second window. Come up with a window that will create the 2 graphs that will look almost identical because they behave the same way towards the outside ends. After playing quite a bit with windows, zooming out with changing my x max to get and x min to get wider and wider, changing my x min and x max to get shorter and taller, I did finally find a window that creates the graph of the original function. You could see the little asymptote there. And then the end behavior asymptotes, they look almost identical, except for that little blip in the middle where the vertical asymptote lies. So we have shown visually that the graphs behave the same towards their ends.